Hello everyone, in this video I explain how to find the equation of the tangent and the equation of the normal to the curve at a point by using the differentiation. Let us restart. This is a curve y equals f of x. And we have here x-axis and y-axis. At a particular point on the curve, like this point, we need the equation of the tangent and normal. So the tangent to the curve is that one. It is a line touches to the curve. So this is a tangent. This is a particular point on the curve. This point is x1 and y1. So, what is the equation of the tangent? The equation of the tangent at the point x1, y1 is y minus y1 equals the gradient of the tangent at this point, noted by m, x minus x1. So this is the equation of the tangent. What is m? m is dy by dx. It is the gradient of the tangent at the point x1, 1. So the equation of the tangent is y minus y1 equals m. What is x1 and y1 is a point on the curve. What is m? It is the gradient of the curve at the point x1 and y1. Now, what is the equation of the normal? The normal is a line perpendicular to the tangent at this point. So this is called normal. It is perpendicular to the tangent. We have a relation between the gradient of the line and its perpendicular. For example, if we have a line L1 perpendicular to L2 and the gradient of the line L1 is 5. So the gradient of the line L2 is negative 1 over 5. We flip and change the sign. So if M1 equals 5, M2, the gradient of L2 is negative 1 over 5. We flip and change the sign. Another one, if M1 equals 5 over 3, what is M2 if they are perpendicular? Negative 3 over 5. Such that M1 times M2 equal negative 1. So, in our equation, the equation of the normal, to the curve at the point x1 and y1 is y, the same equation, y minus y1, but just we flip and change the sign of m. So it's negative 1 over m, x minus x1. So this is the equation of the normal to the curve at the point x1 and y1. Let us go to the past paper question and we take questions from past paper. This examination exercise 2 in the future series, question number 39. Let us see this question from past paper exams. Question 39, page 90 in the future series. Find the equation of the tangent to y equal x squared plus x. This is the curve. And x equals 1. What is the problem here? We don't have the coordinates of the points, just we have x coordinate. So we need to get y coordinate. How to get y coordinate? Just replace x by 1 in the equation of the curve. So the solution starts from this point. So y when x equals 1. Replace x by 1. So it's 1 squared plus 1. 1 squared is 1 plus 1, it is 2. So y coordinate is 2. So the point now, so the point is x equal 1 and y equal 2. So this is the ordered pair of that point. Now, we find dy by dx, the gradient of the curve at any point. So, dy by dx, we differentiate. So 2 comes down, x and minus 1 from the bar, plus differentiation of x is 1. This is the gradient at any point. At our point, at the particular point 1 and 2, we say it is m. So m is dy by dx at the point 1 and 2. So just replace x by 1 in dy by dx. So it's 2 multiply 1 plus 1, 2 plus 1, it is 3. So this is m. Now we have m equals 3 and the point x1, y1, it is 1 and 2. Now we go to the equation. The equation of the normal, the equation of the tangent is y minus y1 equals mx minus x1. This is the equation of tangent. Just we do substitution. So y, this is y1, this is x1, this is y1. So y minus y1 minus 2 equals m equals 3, x minus x1, x minus 1. We simplify. We have to write the equation of the normal or the tangent in this form. So the equation must be written in one of these two forms. Y equals mx plus c, or we write it as ax plus by plus c equals 0. Then we have to write the equation in one of these two forms. So we simplify this equation. So y minus 2, we distribute 3. So it is 3 times x is 3x minus 3. Move negative 2 to the other side. So y equals 3x minus 3 plus 2. So y equals 3x minus 1. So this is the equation of the tangent at the particular point. Let us we see this question 20, page 87. Find the equation of the tangent and the normal to the curve y equal 12 minus 4x plus 2x squared at the point where x equals negative 1. First, we need to get the point as ordered pair because we have x coordinate of the point. So the solution start from this point. Y when x equals negative 1. What we do, replace x by negative 1 in the equation of the curve. So it's 12 minus 4 negative 1 plus 2 negative 1 squared. Take care. If the number is negative, put it in bracket. Now we use the calculator to calculate this value. So the value of y is 18. So the point now as ordered pair, the point is negative 1 and 18. The second step, we find dy by dx, the gradient of the tangent at any point. So the gradient at any point denoted by dy by dx. So we differentiate y, the equation of the curve. Differentiation of 12 is 0 because it's constant. Differentiation of negative 4x is negative 4. Differentiation of 2x squared, 2 comes down, 2 times 2, it is 4x. So this is dy by dx, it is the gradient at any point. At our point, denoted by m, so m equals dy by dx at the point negative 1 and 18. Just replace x by negative 1 in dy by dx. So negative 4 plus 4 times negative 1. Negative 4 and negative 4, it's negative 8. Now we have the point, so the point is negative 1 and 18, and the gradient of the tangent at this point is negative 8. Now we need to write the equation of the tangent. The equation of the tangent is y minus y1 equals mx minus x1. Just we do substitution. So this is x1, this is y1. Remember this one. So this is x1 and this is y1. So y minus y1, y minus 18 equals m. m is negative 8, x minus x1 minus 1. Simplify. So y minus 18 equals negative 8x minus plus. Distribute negative 8 over the bracket. So y minus 18 equals negative 8x minus 8. Move negative 18 to the other side. So we need to write the equation in that form. Y equals mx plus c. So y equals negative 8x minus 8 plus 18. Negative 8 plus 18, it's positive 10. So y equals negative 8x plus 10. So this is the equation of the tangent. Now we need to get the equation of the normal. Just we flip and change the sign for m. So the equation of the normal is y minus y1 negative 1 over m x minus x1. So it is the same here. Y minus 18. So y minus 18. Now negative 8. We flip and change its hand. It becomes 1 over 8. So it's 1 over 8. X minus x1. X1 is negative 1. How to simplify this equation? It's better to multiply both sides by 8 to cancel the fraction. So multiply this side by 8 and also multiply this side by 8. So 8 times y, it's 8y minus 8 times 18. So it's 144. Cancel 8 with 8, so just x plus 1, negative, positive. We write this equation in this form. ax plus by plus c equals 0, so we move all to the other side. So x minus 8y minus 144, it becomes plus 144 plus 1, so it's plus 145 equals 0. So this is the equation of the normal. Now we take another question from past paper exams. As we see this question 46, page 90. If y equals negative 1 minus x squared, intersect with y equals 2x, prove that the equation of the normal to the curve at the point of intersection is y equals negative half x minus 5 over 2. What's the solution? Just we sketch the graph of this one. Y equals negative 1 minus x squared is the graph. So this is y and this is x. Negative 1 minus x squared. So it's open downward. Negative 1, translation 1 unit down. So this is the graph of y equals negative 1 minus x squared. And the line y equals 2x. This is the line y equals 2x. It is a line passes through the origin. Okay, now we need to find the point of intersection. To get the point of intersection, we equate the two equations together. We equate y1 by y2. So this is y1 and this is y2. So at the point of intersection, at the point of intersection, y1 equals y2. y1 is the equation of the curve, y2 is the equation of the line. So negative 1 minus x squared equals 2x. We solve this equation by using the calculator, modify 3, but we have to rearrange it. So it becomes x squared, we move to the other side, plus 2x plus 1 equals 0. By solving this equation, x equals negative 1. So this is x. So we have one point of intersection because we have one solution of this equation. We need to get y. So we go to the equation of the curve or equation of the line because that point lies on the curve and the line. So negative 1 and y. So we can use any one of the equation. Y equal to x or this one. So we find y. So y when x equals negative 1, replace x by negative 1. In the equation of the line of the curve, for both will get the same answer. So negative 1 minus negative 1 squared. Negative 1 squared is 1. Negative 1 minus 1, negative 2. So the point of intersection, is negative 1 and negative 2. The second step, we find the dy by dx. the gradient of the curve. The gradient of the curve at any point. So dy by dx, which equation use it? The equation of the curve. Y equals negative 1 minus x squared. Differentiation of negative 1 is 0. Differentiation of negative x squared, it becomes negative 2x. So m is the gradient of the tangent at any point, at the particular negative 1 and negative 2. So it's dy by dx at the point negative 1, negative 2. Replace x by negative 1. So it's negative 2 multiply negative 1, it's positive 2. So the gradient of tangent at the point of intersection is 2. The equation of the normal is y minus y1 equals negative 1 over m x minus x1. So we do substitution. This is, remember, this is x1 and this is y1. So y minus y1 minus 2 equals, we flip and change the sign, it's negative half. X minus x1, x1 is negative 1. Simplify, minus minus plus, negative half x plus 1. We distribute here, so negative half times x, it's negative half x. Negative half times 1, it's negative half. Move 2 to the other side, so y equals negative half x minus half minus 2. So it becomes negative half x minus 5 over 2. So this is the equation of the normal. Thank you.